Welcome everyone to episode 24 of the Exoskeletons and Wearable Robotics podcast with special guest Dr. Michael Goldfarb, Professor of Mechanical Engineering at Vanderbilt University and the Director of the Center for Intelligent Mechatronics. We're all very happy to have you here with us. And before we begin, a special shout out to our Patreons, without whose support this is not going to happen. Our VIP tier supporters, Volker Bartenbach, Rita Vasquez Torres, Minmar, and our corporate level sponsors, Pumotech, Oxivo, HeroWare, and Digity. Thank you for the support. Please consider becoming a part of the Exoskeleton community. Go on our Patreon page, take a look at all the benefits that you get. And now let's dive right into it because I'm super excited to have Dr. Michael Goldfarb with us. So I did a little research. If I understand correctly, you finished your PhD in mechanical engineering from MIT, and you're one of the first people to make a successful robotic ankle. Well, would you say that that's accurate?
Sure. Tom is one of the guys to make a first successful ankle.
There's a bunch of us have worked on it.
You're also the developing force behind the Indego exoskeleton, which was part of Parker Hannifin and then got sold to Exobionics. So you definitely know your way around exoskeleton technology. You've done work with prosthetic hands, and you've given not one but two keynote speeches at the WeatherCon conference. One time in 2020, the Indego exoskeleton, and I think one time in 2017, functional electrical stimulation integration, and the importance to have intent be part of the movement profile when doing medical rehabilitation. Coincidentally, just this week, there was another study on that. This time, Cyberdyne with the HAL exoskeleton were again saying the same thing, that you need to capture that intent. So thank you so much for taking the time to be here with us.
Yeah, thank you. I'm very happy to be here.
Awesome. Well, can you tell us about your work? Like, what got you interested in this field? I'm eager.
So yeah, what got me interested in this field? For some reason, I have been interested in augmenting human movement for a long time. I've been interested in augmenting human movement since I was in high school. I'm not sure what generated that interest, just some combination of things like a fascination with human movement, fascination with the human body, a desire to make technology that tries to help people. And the focus of a lot of my work is trying to improve mobility or functionality for people with physical disabilities. So for me, that has another kind of layer of hopefully of trying to benefit people with technology. So I've been interested for a while. I worked in a prosthetics lab in a VA hospital while I was in high school. And so that kind of reinforced some of my interests. And then throughout college and graduate school, used the opportunities that I could to work on, related work. So I did a 1-year project developing a upper extremity prosthesis in college. And then in the summers, I worked at a VA rehabilitation R&D department working on a prosthetic foot. Not a mechatronic one, but a compliant prosthetic foot that had ground conformation capabilities. And then in graduate school, worked on a prosthetic knee, and then also later on a hybrid FES exoskeleton. So kind of been interested for a while and have tried to, create opportunities to educate myself about it and contribute to the field.
Where do you see that line between, sometimes things could be exoskeletons, sometimes things could be orthoses, sometimes things could be medical. Do you see that line, or do you mainly just focus on the medical side, or how do you see that? You know what I mean? Where you could think of an ankle orthosis can be similar to an ankle exoskeleton just to support, an able-bodied person. So I'm just thinking about some of the work you've been doing.
Yeah, you mean the line between prosthetics and exoskeletons, or the line between addressing impairment versus augmenting healthy?
Well, maybe you could talk about both. Impairment versus augmentation.
Yeah. Let me start with that. There's obviously, a lot of overlap in trying to address impairment for people with physical disability or or some other kind of musculoskeletal impairment. And a big difference between that, well, there's a lot of overlap between that and augmenting healthy movement, but there are also big differences. I think one of the differences, for example, is you can argue that it's easier to add value to people with physical disability because the performance bar is lower, right? I mean, healthy people are so good at what they do. The performance bar is extremely high, right? To make them better, you can do it. I mean, this isn't an exoskeleton example, but a bicycle makes people a whole lot faster. And so you can do it, but again, the human performance bar is very high, so it's difficult to do. But there are other aspects where maybe it's more difficult to augment. Healthy people are very robust and are pretty good at adapting and learning how to leverage assistance. And so if you give them a little bit of assistance, and especially if it's like fairly consistent, I think they're quite good at adjusting. I think it's less important to provide coordination to healthy people because they have that coordination. They're just looking to, for some kind of power input that they can leverage. And so I think that is a difference in the problems. I think that in other senses, it's a lot easier to be a disturbance to a healthy person because, again, they're so good at what they do. It's kind of like a healthy person moving, especially in terms of like locomotion, is just a finely tuned machine. And you can do a lot of things to disrupt that fine tuning. And so finding how and in what manner to inject assistance can be a real challenge. There's problems that obviously have a lot of overlap, but they have a lot of separation too. And for my own part, I've worked on trying to improve mobility or functionality for people with disability because I think, that's a need that aligns well with, I guess, I'll just say, my interest in trying to improve quality of life of people. And I also think it's in some regards, an easier problem, easier to make a big difference because, or a difference because you're starting from something, of course, a lot more deficiency, right? So then you're trying to address that deficiency as opposed to with a healthy starting from already like pretty outstanding performance and then trying to make that even better. So anyway, I think both are super interesting problems.
Right. I mean, yeah. So that was interesting.
Let me then rephrase the question slightly differently. So this is something that Tom and I would honestly say at this point, waste a lot of time. We would look at a device and we have no idea if we're looking at a orthotic or an exoskeleton. So at the end of the day, does it even matter? Is it just semantics? Like if you're a student trying to learn this technology, if you're starting a company, does it really matter if it's a medical exoskeleton or a medical orthotic device?
I don't think so. I think, as you said, it gets down to semantics. When we started working on the Indego, I tended to call it a powered orthosis, not an exoskeleton. So, orthotic medically is just something that's worn on the body to help add, functionality, provide support, improve mobility. So powered orthosis was what we chose to use. But I think the rest of the field really liked the term exoskeleton. So I don't use the term powered orthosis anymore. But to me, it's the same thing. And when you talk then about like a passive exoskeleton, that gets even a little more confusing because the passive exoskeleton to me kind of is an orthosis. And so I think there's as you said, I really think it gets down to semantics. I don't know which word is a better word, orthosis or exoskeleton, but I tend to use them interchangeably. And if I'm speaking to a technical crowd, then I'm going to use exoskeleton. If I'm speaking to a medical crowd, I'm more likely to use orthosis. Okay. Because that's the language, the respective languages of those communities.
So what I'm hearing is that adapt the language to your audience, but don't get lost in the detail. At the end of the day, we're trying to help people to restore functionality that they may have lost.
Yeah, I would say it's a wearable robotic device, which it is. But really, I'd say again, when you get to passive devices, which certainly are exoskeletons, there are a lot of really good passive exoskeletons, right? And so then it's just more of a wearable device that physically interacts with person.
Thank you. Yeah, this is gold. Like this is something that There's discussions all the time. I've been in multiple dozens, if not hundreds of hours of committee meetings where this is being discussed. This is important for obviously Google on how people search for information. It's important for patent applications. So to have one of the leading people with decades of expertise for you to be able to weigh in on the questions like this is pure gold.
Okay, great. That's all I'm doing though is weighing in. There's no, nothing definitive in my perspectives.
Yeah, well, it's an emerging technology field. If anyone claims that they have the definitive answer, what are they doing on this podcast? Go make money.
Okay.
Right, but I mean, there's been a lot of terms out there. Remember the original term, Bobby, one on this, but the original term.
Oh, there's been so many. There's been
Terms.
biomechatronics, power suit, you name it. I'm seeing a trend with the medical exoskeletons where people are trying to adapt the challenges and the way that they're being evaluated to include tasks of everyday living. So, for example, we saw that with the Cybathlon, where the first two iterations of the medical exoskeleton race with the Cybathlon was to be able to go from point A to point B. Worst case scenario, move at an incline, go upstairs and open and close the door. Now we are seeing challenges like get a soup and move that soup from the counter to the table while inside an exoskeleton, something that would be relatively trivial inside a wheelchair. We've also seen the same thing with the Toyota Mobility Challenge from Japan, where they have this like fake see-through one-bedroom apartment, and they try to get exoskeleton technology against challenges of everyday living, be it like someone delivers a package at the front door. So you need to go to the front door, open the door, bend down with the exoskeleton, pick up the package, go wash your hands, go use the bathroom, and so on and so on. So I'm seeing people trying to take this mobility enhancement technology and now challenge it against tasks of everyday living. Are you seeing that as a trend, and what are your thoughts on it?
I'm not aware of it as a trend, but also I'm not, I don't know that, I mean, it sounds like not a bad trend. My thoughts on it are, I guess first, it's good for people to start thinking about tasks other than just walking, right? I think the more you can understand how something might be used in the real world, the more useful it will be, right? So I think, and especially to get researchers thinking about that, I think is super important. I kind of see both, not only in the exoskeleton, but in particular in the prosthetics community, research community, that it's been only really in the last 10 years or something that people, maybe a little bit longer than that, but people have really started focusing on a lot more things than just level walking well. I think that's super important. However, I also think that what activities make sense depend on how an exoskeleton is to be used. And so if you're testing it in an activity in which it's unlikely to be used, then that's not too useful either. The way I see, by the way, like when we were developing the Indego exoskeleton, I always thought about it as kind of two things. One is the recreational device. So you can, well, let me put it a different way. It wasn't going to replace a wheelchair for mobility. The wheelchair was going to be your primary means of mobility, but it would do a few things. It would be, I'll say, a recreational device in the sense that it provides upright, weight-bearing mobility, which has certain health benefits. So people, for example, with spinal cord injury, a lot of them just stand for 20 or 30 minutes a day in what's called a standing frame. And so if you can like stand and move around, that's a lot more, that's an improvement in your quality of life, I think. And so that's one. Another is mobility, but access to places that are otherwise inaccessible to wheelchair. I think that's an important application. So for example, we had some of the people who helped us test, one guy in particular was a football coach or an assistant football coach, and his team got tickets to go see a professional football game, and he couldn't go sit with everybody else. He had to go sit in the wheelchair section of the stadium, right? And so he would have really liked an exoskeleton so that he could access places that were otherwise inaccessible to a wheelchair. And then I think thirdly, there's so many social situations where you want to be kind of eye to eye with somebody. There's like it's interesting, but a lot of the conversation, so to speak, happens at a certain level, let's say in social gatherings, whether it be, I don't know, at a party, just an event, whether it be walking with somebody through a park, right? You're walking with somebody through a park and you're discussing and you're kind of, the conversation's happening at the level of your head and shoulders. And it's a lot more difficult when somebody's up here and somebody's down here. So, I do think there are other potential useful applications. For example, another thing that we considered is shopping, right? And reaching things on the top shelf. But so I think all of those are good. And to the extent that having competitions or assessments to make people aware that it's good. But then if in your competition, you're doing something that somebody's just not going to use it for, right? That it's not intended for, then that's not necessarily that helpful or meaningful. So I guess my answer is I think it's a good trend, but it also, the tasks need to be relevant to how that device is intended to be used.
Thank you. Excellent. And I just want to chime in for our viewers on YouTube and listeners everywhere else. We have it easy in the United States where there's ramps and elevators and very, like I would say, relatively thorough laws on accessibility. Try going to Europe or other places in the world. Try going to like a medieval town as a tourist, or if your family has property there, you might literally be dealing with architecture from 1,000 years ago. Some places have the original Roman roads to this day. You will struggle with the current mobility aids that are available, and being standing, having the ability to walk will all of a sudden become a lot more transparent and obvious.
That's a great point, because when I'm in Europe as a tourist, I have that thought all the time. I'm just thinking, I'm walking over cobblestones or walking, into places that there's just no way, right? You're going, it's very inaccessible. And I always have that thought that, boy, this would be really tough. And so I think that's one application where, again, you're going to, these kind of devices can afford legged mobility into places that aren't otherwise accessible by wheelchair. So I think that's, clearly one of the places in which this is, these aren't a panacea. I think they're devices, you're not going to put it on in the morning, I don't think, and wear it all day, and that's going to be your primary means of mobility. But they do enable you to have a lot more access, right? Access and participation. I think that's where I see one of the real benefits of exoskeleton, at least for people with spinal cord injury and other kinds of, substantial, other people who have substantial mobility impairment.
Tom, your question?
Yeah, so I had a couple questions. One was, you thinking back, you've done a lot of work on, original work on powered ankles, powered knees, and then you work, Indego. You also had a hand device that you were working on. I remember also you were working on some, what I would call not passive, but not active, more like quasi active things where, you turn clutches on and off. So to help someone's elbow. If you look back, what were some of those ahas? Like, you're like, wow, I was really proud of, such and such. Pick one or two. Like, you don't have to pick one, but pick one or two. Like, tell the audience, like, hey, I think we really, we moved the field, right? We moved the field in a couple ways, with a couple of devices. Which ones do you think you're most proud of? Or there's a lot there, but I know there's a ton of students and a ton of things out there, but I mean, you've done seminal work with the Indego and the knees, and ankles, but also you were just doing sometimes simple stuff where I remember you had a clutch where you could clutch the elbow and kind of lock the elbow so someone could hold, a can of soup, right? And then use their other hand to take the lid off or something,
Yeah. Okay. I will say, I'm trying to tie everything together, although I know I don't need to, but I think one aspect that I've come to appreciate more and more over past 30 years is to leverage passive behaviors to the extent you possibly can. So I think as a mechatronics robotics person, you're looking for opportunities, and I don't mean that in a negative way, but you're looking for how can I make things better, right? So for us, for my group, that opportunity, I think, certainly started starting in the mid 2000s, so 2005 plus, was, and I know, Tommy, you worked on this as well, but how to add power, right? The motors, batteries got good enough so you could add motive power. And it seemed like there was a tremendous amount of opportunity to do things in a way to provide functionality that could not have previously been done. Now, and also, I don't want to say that other people hadn't thought about doing that. There's that, if you go back to the 60s, there were those, great symposium on the Vuko Brodovich stuff, the symposiums on cybernetics, they called it. Yeah. So they didn't want to do it for a long time, but around 2005, 2010, then you could do it. So then where's the value added? And so we got real excited about power. We're still excited about power, but over that time, I started realizing more and more how important passive means are. So, and it doesn't have to be one or the other, right? So I think you can do a lot passively, and I think people should be, I don't want to say what people should be doing. I think there's a lot of opportunity to try to do as much as you can passively and then do the rest with power. So that's kind of I'm not framing this as in, because Tom, you kind of asked it as in, well, where do I think like is the big, I've maybe potentially had impact on the field, but this is more of a lessons learned. I came to appreciate how good some of the passive devices are. And just as an example here, now I'm thinking of a different thing too. So let me get back to that one in a minute. But the passive devices, and if I want to think in terms of, well, I think you could think in terms of a lot of things, but it's a terribly simple device, but an AFO is an incredibly good passive device, right? A carbon fiber prosthetic ankle is an incredibly good passive device. A passive knee prosthesis, for instance, the Malk, which is a incredibly clever device. For people who don't know, that it's a hydraulic knee prosthesis developed by Hans Malk in, I'm going to say the 60s, but he started in the 50s. He was a former World War II aerospace engineer, German aerospace engineer, who came over as part of, like, I'll say the brain drain from Germany, and then turned his attention to, worked at Wright-Patterson Air Force Base, but then his real passion was doing this prosthesis stuff. So eventually to start doing prosthesis. He developed incredibly clever prostheses that work really well. And so I guess I've been trying to appreciate more and more, doing as much as you can passively, and then using power not everywhere, but trying to be very surgical in the way power is used, and using it to best effect. So so this general notion I kind of have been calling lately powered on passive. So make devices that work really well passively, and then the power should be an add on top of it. So that's something I think I've slowly come to appreciate, how good the passive devices are. And that was, we started making powered knee and ankles, and let's say I'm going to call it between 2005, 2010 is the general time frame, and they work really well, and they do some things that passive devices don't. But over that time of working with tens of different people who tested and where are those devices, and I also observed how good those passive devices were. The passive devices still have deficiencies, but I guess my point is, you don't necessarily have to throw out everything that's been done before. Learn and appreciate how good those things are and build on top of them. So that's one thing I feel like I kind of learned. Another thing that I feel like I've kind of learned is the value of mechatronic systems. So I tend to think, in design, I think, and this is not just me, a lot of people, of course, think that the best solution is the simplest possible. There's an Einstein quote that the best model is the simplest possible, no simpler, right? I think that goes for design. The best design is the simplest possible, no simpler. And so, like, what that is exactly, of course, is not clear, because the no simpler part, of course, makes it very unclear. But the simplest possible that does everything you need it to do, right? So I definitely, try to subscribe to that. And so then the question is, well, can something like, let's say, a Malk knee, is that sufficient to provide all the functionality? I guess another way to say it is you could ask whether or not making things robotic / mechatronic, how essential is that? And I think the answer is it depends, but I think there's for me, a good kind of example. I worked on kind of what was the predecessor of the Rio knee, right? And that was my master's work in graduate school. And I kind of thought after I finished that, I kind of thought a little bit of so what, so we put sensors on something and we could tell when somebody stood on it and made it high resistance, and then when somebody was entering swing, make it low resistance, so on. But I did question how much value there would be. After 30 years of working with people who use microprocessor controlled knees, I've become convinced of the value. And so I think and the reason why they have so much value is because it's so important. Let's say in that example, a knee has to go from very high impedance to very low impedance. High impedance during stance, where it has to, it has to provide support for your body weight.
Mhm.
And then in swing, if you swing ballistically like those devices do, then it has to switch to very low impedance, and it has to do it at the right time so that you can swing your leg forward. If it gets either of those wrong, if it's high impedance when it should be low or low impedance when it should be high, you're likely to trip or fall. Right. I mean, it's kind of obvious if it's low impedance when it should be high, you're going to fall because your knee's going to buckle. But also in the other case, if it gets the other thing wrong, then you try to swing, you swing with a stiff leg and you kick the ground, and you may not fall, but it's a big perturbation and you may fall. So anyway, it's got to get those things right all the time. Doing that mechanically is really hard because you don't have the awareness of when to do what you got to get it right. And there's so little room for getting it wrong. And something like a mechatronic system, which has a 6-axis IMU and has load cells and has other things, has a set of information that a mechanical system there's no way the mechanical system could have that. And so the mechanical gets it right most of the time, but then gets it wrong. Let's say if you get it wrong 0.1% of the time, you're still going to fall once a day.
Right.
That's not acceptable. And so the mechatronic system gives you so much greater awareness that I've been convinced that there's real value in it. Sometimes I think engineers are guilty of pushing high technology into places where it doesn't need to be. But I've convinced myself that there are definitely applications where going with the robotic mechatronic system is superior. And that's, that knee example is one. I'm sure there's a lot of others. But so, to me, again, that's not a contribution that I've made. That's just a lesson learned or something I've come to appreciate. There's clearly applications where you don't need it and it's not necessarily going to be helpful. So I'm not saying you push that kind of high tech microprocessor controlled behavior into every application. But at the same time, there are definitely applications in which I know that creates value, and it's important value. And it's frankly, in that case, as I mentioned, it's value that keeps people from falling. I won't tell you, but I've got a lot of kind of anecdotal stories of people who have MPKs, and then their microprocessor knee has to go in for servicing, and then they borrow a mechanical knee from their prosthetist, and they're walking down the hall holding a cup of coffee and just on the ground, and then I worked with for a while, kind of relayed that story to me and said he got up and was like, "What was that?" And then he got up and walking again, and just several steps later on the ground. Whereas with his microprocessor knee, never fell. So it's that awareness, and it's really being able to do the right thing at the right time in the presence of a lot of perturbations. Because when we walk, it's not a perfectly repeatable pattern. So there's perturbations, environment changes, we change, and so on. Our shoes change, and so anyway, clear value there. So that to me is kind of I don't know if it's a lesson learned, but something I come to appreciate.
Mhm.
There's definitely applications in which the robotic approach to things is going to be better. But as you both know, that's not every application. So finding that application, finding where it has really, real strong value added is kind of what, I think is the job of the engineer at this point with respect to wearable robotics, right? Finding that application. There's a lot of other stuff, but you got to start there and understand where that really has value. And then again, for me, I feel like one of the big things I've learned is to appreciate passive behaviors and do as much as you can passively, and then do the rest. Maybe if there is role for power, then do that on top of passive behaviors. And then I'll just real quickly say, Tom, that's a lot of I think what you did in this in the Sparky, right? Kind of and build everything around the fundamental passive behaviors.
Yeah, we were trying to pull on the spring at the right time and try to store as much energy in the spring as we could. I don't know if people, thank you for saying that. I don't know if people realize as much as we did, where we called it translating potential energy, where you pulled the spring, translated the spring, and then dumped the energy out. And there isn't many people that think about, they think F equals KX, and we thought about F dot equals K times a relative velocity, which was kind of an interesting term. But thank you. But yeah, so that leads me, there's two things that leads me into. One is, where's the field going? But let's hold off on that question. But the other leads me to is, we've asked this question of some others. Why do you think then, on the powered systems, why do you think like the powered systems haven't taken off as fast as we thought, right? 'Cause I mean, let's be honest, Wearicon, we thought there'll be a ton of people wearing powered exoskeletons or powered devices, and we haven't seen as much of that yet. And so what do you think, where do you think some of our drawbacks were? Is it a marketing issue? Is it people don't want to be seen wearing something? Is it cost? Is it, I think what you're saying there too, like maybe we were augmenting something that, some of the passive systems were good enough. I've heard that, from people.
Yeah. Again, I think the field is in a place now where it needs to look for best use of power and the applications in which there is real value added, right? So to your question, why haven't powered exoskeletons been as, I'll say, successful or as well as quickly adopted maybe as otherwise one might have thought? And so I think part of that depends on what application and what field. If you talk about healthy human augmentation, such as some of the early work was load carriage, right?
Yep.
And I think it's because they don't move with people well enough. I think there's several things. The human body, healthy human body, especially if you took like a soldier, it's a high performance system. And so you want to improve the performance of that system, but you have these really difficult challenges of, I guess, coordinating the movement, the healthy person has their own control system, their central nervous system, and the exoskeleton is not tapped into that system, does not have direct information as far as what it is the person wants to do. And again, I think human movement is so finely tuned and so optimized that it's probably more sensitive to being disturbed, than it is to being helped, if that makes sense. So if you do something at just the right time and you add power at just the right time, just the right way, you're going to help. But there are a lot more opportunities to get in the way. And I think that's kind of, we'll call that a control issue, a coordination issue. When we did the Indego, we started with people with complete spinal cord injury, as opposed to people with partial spinal cord injury, or people with other impairment, such as from stroke or from post polio or other aspects. So you've got this whole range of people who can't walk at all to people who can walk but walk with impairment. So I call people who can't walk at all non-ambulatory, and people who walk with impairment poorly ambulatory. And we started with the non-ambulatory as our intent for a few reasons, but one is we thought, well, that might be a harder problem because we have to do everything. The person can't help. So, and in some respects, it can be a harder problem, and in some ways it is, but in the control sense, it's not, because you don't have this other control system that you have to coordinate with, and that if you don't coordinate with it, you're going to be getting in the way. So that problem where you're making an exoskeleton to move, for somebody who has complete paralysis, you have no competing system, and you don't need to finally coordinate the movements of the exoskeleton with the movements of the person. So then later we started looking at, well, what about poorly ambulatory people? So let's say just somebody who walks with a limp, right? And you want to kind of erase their limp, but the exoskeleton is no longer in charge. The person's in charge. The person doesn't want interference. They want help, but it's really challenging to know how to help somebody in a joint-wise way without getting in their way. And again, they have this control system that unfortunately you have I won't say no information about, but you have extremely limited information on what neurons are firing, at any given time. So I think there's much more room, much more likelihood that you might get in their way. And the first time you get in somebody's way, even if you're helping, let's say you're helping 90% of the time, but 10% of the time you're getting in their way, people are going to be like, no, don't need it, and especially somebody who's poorly ambulatory, it becomes a trip hazard. It does something wrong, again, 10% of the time is, if it does something wrong 1% of the time, if every 100 steps, it's kind of like it becomes a perturbation and you might fall, then you're just going to say, no, thanks. And so I think, again, I haven't done work. I hesitate to speak on healthy augmentation problems because that's not really what we do. But I think at the same time, yeah, you want to help somebody, but there's so many opportunities to get in their way. And once you get in their way once, I think they're just going to say, no, thanks. And part of getting in the way is not just doing the wrong thing in terms of control, but people move in a way. We talk about powered systems and this is something I've been thinking about lately, but is that in robotics, we tend to force movement all the time because we're conditioned to do that. And we think about, let's say, like trajectory control and whatnot. But the way people move is to kind of go back and forth between like forced motion and passive motion. And we humans leverage passive motion all the time. And so we're not just like this always power positive, through our joints. Our muscles push a little and then glide a little and push a little in different stages, right? We leverage passive dynamics heavily, and robot actuators aren't really set up to do that. They can't glide very well, if that makes sense. They can push pretty well. They can't glide very well. So we kind of we don't think about controlling things in that way, in the same way as the biological systems. And we don't have actuators at this point that really could support the same kind of movement if we wanted to. So anyway, one reason I think what that boils down to is I'm not sure we yet know exactly how to use power to best effect, and certainly power is going to, certainly I think we can improve movement even for healthy people with power. It's just that, we're still learning. We as a field are still learning how to use it to best effect. That's the way I see it.
So I'm dying to ask, we live in a time where everyone is talking about AI, and I think it has become impossible to distinguish between hype, pure dreams of what AI technology can do, AI capability that is realistically down the road, outfits saying that they have achieved things with AI. It's like, trust us, put money into our project. There's a box in here. Inside the box is the AI, and it has solved all the problems. We just need a little bit more investment funding. And then there's also skeptics that are technology skeptical that will go in the other extreme, where they will see the value of AI technology, but say, no, I'm still refuse to use it. So I'm seeing a tsunami of articles and wish listing how you're going to get a large walking data set from a user. You're going to feed it through AI, and I'm doing air quotes, and then it will solve magically all of the power application challenges. So what the two of you have mentioned now repeatedly, applying power at the correct time and knowing when to get out of the way at the correct time. So I think 99.99999% of the population at this point is completely confused as to what AI can and cannot do about this challenge. Could you please shed some light on this?
Yeah, well, I can attempt. By the way, you said in a few words what it took me a long time to say, which is the powered thing is all about being able to apply power at the right time and get out of the way at the right time. Because that's the essence, I think, of the problem that needs to be addressed. And so the question is, can AI address that? So I got to say, I am an AI, I guess I'll say skeptic, but, maybe that's only in light of all of the hype, right? So it definitely has applications. And And sometimes it's not even clear to me what AI means, but I think that, and then I was sitting in a talk yesterday, the day before, using the term deep learning, and that's like not even, a lot of these are like notional terms almost. So AI, I think with respect to our field, probably means different ways of machine learning. And I think, your question to some extent is, what are the prospects of using machine learning to address the problem of coordinating exoskeleton actions with a user, right? And as you said, a lot of people are doing that. And I do think there's potential there, right? And, in what we do in research, there's a lot of problems and a lot of different ways to solve problems. And so no one person can come at it and say, that's not a good way to solve a problem, because a research community figures out best practices by a lot of people taking different approaches, and then eventually we see what all approaches can produce, and then we eventually can kind of adjudicate, right, which approaches seem to work better, and that can be either, again, which one is, maybe they all work similarly well, but one's like a lot simpler than the others, or maybe one has shown the most robustness, or whatever the case, right? So I don't want to say what people should or shouldn't be doing. So I think the people who are looking at that, trying to address the control problems of exoskeletons with AI or machine learning or whatever you want to call it, I think that's a good pursuit, because otherwise we won't know, because doing it's kind of the only way to tell. But I do think that, to some extent, it's a black box approach. I'm not a big fan of black box approaches. There's, you're training on certain amounts of data and then testing on other amounts of data. And so the only way eventually to see if it works on a really broad, realistic set, right? Does it work in the wild on a whole lot of different people? That's going to be a difficult thing to know. So I guess I have a little bit of skepticism about how well one is going to know that in what would be the relatively small markets of, exoskeletons. I, again, don't want to be too critical of it. I don't think it's a panacea. And I do think you have, this line of questioning actually makes me think of a different related one. And and Tom, you asked the question a while ago about, like, what do I think I've learned? Another thing I think I've learned is that you don't always want the machine trying to infer what it should do. I think there's the idea, if a person changes what they want to do, that the person just does what they're doing anyway, and the machine infers everything, right? And then there's the other idea which would be like the implicit communication, I guess, between the two. And then there's the idea of explicit communication, where the person actually kind of tells the machine what to do. And you don't have to be on one extreme or the other. But one of the things I've learned is people want agency. When they're wearing a device or in a device, they don't want to guess at what the device is going to do next. And, they want pretty much to have full agency, full decision-making capability. So if the device is making any decisions, I think or let me put it a different way, the device, I think, can make decisions to the extent that the person doesn't know that it's making decisions. If the person is ever aware the device is making its own decisions, they're going to be very uncomfortable with that. So my example is something like ABS brakes, where, the car is underneath you doing a lot of things, but you've stepped on the brake and the car's stopping. It's doing what you asked it to do. It's not deciding, oh, maybe this person doesn't want to stop. So that's not going to work out well. So I think you can have a lot of autonomy or semi-autonomy as long as a person doesn't know about it. And so, there's so when you use AI and machine learning, to some extent, some of what you're trying to do is learn what it is the person wants you to do. Sometimes I think it's okay, not just okay, but preferred for the person to actually give the device some explicit cue that says, this is what I want to do. So it doesn't mean the person has to be pushing buttons on the device. It can be inferred from movement, but I think the person really wants more to give commands, even if that they want more to give commands to tell the device what to do than they want the device inferring from what they're doing, inferring what it should do. I think I mentioned that because I think it's something that we've learned, right? I mean, for me, originally the idea, I remember when we were doing the first powered leg, And the thought was, we just want somebody to approach a set of stairs. And then when they approach the set of stairs, because they see the stairs, they're going to move a little bit differently as they start to transition from level walking to stairs. So we want the device to recognize that change in pattern and then adapt, to do what it's supposed to do. And I don't think in reality that people want that. I think it makes them very uncomfortable. I think they would rather, have some slight cue that's maybe fairly natural, but also has intentionality in it. And by that slight cue that has intentionality, they're effectively telling the device what it's supposed to do, but telling it in a very convenient language, if that makes sense. So the idea of AI inferring everything, I think can be problematic when you get to the users being uncomfortable. But I think another important thing for a device to do that I've learned is tell the person when it's going to do something different. And obviously I don't mean like speak up in a language, but give some cue. If it's a pattern movement and it's continuing to do kind of the same thing, then fine, don't do that because that would be bothersome. But if it's actually going to change its behavior in some significant way, let's say going level walking to upstairs, tell the user in some way, maybe some vibrational cue or something. People, again, want to know what the device is going to do. So I think ideally you make a device that really just kind of has one set of behaviors and the person doesn't have to guess what it's going to do at any given time. But sometimes because of the nature of what function you're trying to provide or replace, the device is going to do different things. And I think the device should somehow implicitly convey that to the user that it's about to do something that it hadn't been doing before.
Thank you. Thank you so much for your input. I want to chime in here with some observations on my end over the last few weeks, which goes back to our question on even the difference between able body versus people with movement impairment. So in this case, I'll phrase it differently. I've noticed that consumer exoskeletons, which are meant to be on able body individuals, will let you take a few steps. Let's say you're on level ground. They will let you take a few steps, make sure that the exoskeleton recognizes the pattern, and then and only then activate once it already sees the pattern. Because normally once we start walking, we walk for at least a few hundred steps to get from point A to point B. Same thing with stairs. If you're walking and so all of a sudden you stop to be in front of stairs, a consumer exoskeleton will actually let you take a few steps first and then recognize the pattern. Oh, this is now stairs that are being climbed. I will now chime in after the second, third, or fourth stair has been climbed. What happens with occupational exoskeletons and medical exoskeletons is you don't have that luxury. You are expected that you're helping from the first movement, especially in occupational settings. Many of the injuries happen in warehouses at the initial point of contact. You see a box, for example, your brain thinks that the box will have some weight based on your experience in that warehouse and the size of the box. And lo and behold, it's actually full of metal plates. You didn't know that, and now you have really tweaked your back. So occupational exoskeletons are expected that from the initial movement, they will be helping. Medical exoskeletons are expected that with every step, including the initial step, or heaven forbid, sit-to-stand challenges, that they will be helping. So when we're talking about here this whole discussion on control, it's important to remember that for this conversation, we're talking about exoskeletons which are expected to be helping with each and every step.
Yeah, that's interesting. But I've seen people say, my system can calculate exactly what's happening 90% of the time. But I remember when we were doing some robotic ankle work, you were doing 5,000 steps a day. And so if you're off, 10%, you have what I would call 500 hiccups, and people aren't going to accept that, right? And not want to wear it. The other thing that I thought in my mind a little bit too is you brought up the ABS thing, and I was always thinking about cars where the human puts an input to a steering wheel, and a steering wheel is power steering. So the steering wheel is putting power into the system. You're giving it an input. It's helping you. And so why is that such a successful thing? And then I thought about it, over the years, and it's getting what you said, which I really liked, is that exoskeletons are actually harder because the power steering, you kind of like making it go this way and then making it go that way. But it's pretty much the same stiffness, the same, not exactly, but somewhat the same impedance. But I like what you said, where an exoskeleton has to give power and then glide, power, glide, power, glide. So it's almost like, push the back of a swing and then let the swing go. Push the back of the swing, let the swing go. But you better push the back of the swing at the right time. And I think that's where exoskeletons are hard. So this is why it is a hard controls problem that, I think we've all been talking about here, where how do I build an actuator that can be stiff and then soft, or I love this term today about I got to give power, then I got to glide, power, glide. How can I do that? How can I understand what the human wants? And I liked what you said too. Human wants agency. And I remember this too. As soon as the person gets scared, if they're wearing an exoskeleton and then they get nervous and they get scared and they don't feel like they have agency, or they're scared of the device, it's finished. It's finished.
Yeah, which is a whole topic of trust.
Right.
That I was in a webinar by the National Safety Council yesterday, great webinar on occupational ergonomic devices, and one of the speakers made a statement that we always focused on the big T being technology, but the big T that we need to focus on is user trust, that the user is trusting the device, that the user is trusting that it has a best intent. And while you're doing the summary, I also want to mention, I think, Dr. Goldfarb, you said that people want to feel that they're in control. I think the majority of people that drive vehicles don't know that they even have ABS brakes, and they don't know that they have power steering. I think very few drivers have driven vehicles without power steering, where you have to turn the wheel yourself. I think most people on the road right now think that they are actually turning the wheels themselves, and they don't realize that that's not the case. In some cases, it's a complete joystick. In some cases, the steering wheel is not even connected to the wheels anymore.
Yeah. So it's interesting. Yeah, interesting.
My wife has this car. It was a Volkswagen, but it has this lane assist. I mean, have you all driven cars with lane assist? So it's got a motor in the steering wheel, and if you try to change lanes without using your turn signal, it'll push you back.
Yes.
And I mean, the idea is, of course, like if you're actually not trying to change lanes and you're falling asleep or somehow other drifting off the road, then it will help you, right? But I turned it off because I find it really irritating that, it's often trying to fight. I felt like trying to fight what I'm trying to do. So I think that's kind of a close analogy to an exoskeleton where, yeah, in that car, the power steering's fine. Doesn't try to fight me, tries to help me, right? ABS brakes are fine. I'm not even aware that they're there. But when it starts to challenge my agency or my intention, I'd much rather not have it. So
it's funny. I get into a rental car and I open it up and I start turning off some of the stuff, because some of them aren't bad. Like they'll vibrate the seat. Like, so. Yeah.
I hate that sound.
I thought that's better than. Sorry, we're getting off the subject. I thought that's better than the lane assist. I'm with Professor Goldfarb. The lane assist, if it, like, I want to, like sometimes, like you're coming up towards a truck, I don't have time to hit the turn signal. I just want to change the lane and get, I'm just, in Arizona, you can drive fast in Arizona. So you want to just make the lane change fast, right? And and it's funny. So anyway, there's all these types of stuff. We'll see what people like, but yeah, I mean, the new cars are gonna, are you gonna not have a steering wheel, right, in the future, right? Who knows? So anyway.
Yeah, I don't know. Some people would go for that. For me, that would terrify me to not have a steering wheel. So I'm gonna keep cars with steering wheels.
Me too. But I say to people, I'm a mechanical engineer, so I know how many things could go wrong. So I'm actually kind of scared of some of those systems. But anyway, so maybe we can end on, where do you see the wearable you've done a lot. You've done powered, you've done the microprocessor knees, and then you did power knees, powered ankles, the Indego systems. where do you see this field going, do you think, in the next?
I feel very fortunate that I'm working in the field at a time when all of this has become a reality. Because as I mentioned, in the 60s, people wanted to do this, couldn't really do it.
Yep.
My advisor did work in the early 70s, same thing. People wanted to do the work. And so we're of the generation that's been able to make things that people can wear and wear outside. And so I'm immensely thankful for that. But I think as far as where the field is, I think it's in an exciting place, but it's I think looking for best practices and best use of power to using power to best effect to help somebody do whatever it is they're going to do. So of course that's different for military exoskeletons, for healthy augmentation, or for industrial exoskeletons, or for people with mobility impairment. It's different across all of those. That's one of the reasons that it's exciting is, and it's not even the same within, as I tried to mention before, let's say it's people with mobility impairment, how you use power and control to help provide mobility to somebody with a complete spinal cord injury is going to be very different from the way you do it to help somebody walk more easily and safely. So, somebody who's had hemiparesis from stroke. Like those are very different problems. And there's so many, obviously in all the industrial exoskeletons, there's so many different tasks. And so I think it's in an exciting place in the sense of it's in a place of exploration and discovery. But that discovery is best practices in terms of design and control for, to use power and use the idea of an exoskeleton to best effect. So that's a non-specific answer, but I think honestly that's where the field's at, which is, if I'm anybody, I mean, a young person wanting to get in the field or a person who's in the field, I think it's a great place for the field to be.
Well, thank you so much for your time, for your input. To all of our listeners, you basically got a third keynote speech here for a digital mini Wearacon. If you enjoyed this, please support us on Patreon. We really appreciate it. It's both a financial support and it's also moral support. Take a look at our weekly newsletter. It's weekly because there's just so much happening right now in the exoskeleton industry that if it was a monthly newsletter, it would have literally 45 items, 50 items. We also have a mini job board towards the end of it. Take a look at our other episodes that we have. Check out the exoskeleton device catalog. We try to keep it updated as much as possible. Wearacon Europe, another great event with another exopark. I can't wait to have coverage from that as well. Thank you all for your time.
Can I say one other thing, which is I really appreciate that you both are doing this. I think it's an incredibly important forum. And so we talked about figuring the field as a whole in a state of exploration in terms of where it should go. And I think a forum like this is essential to that happening in a cohesive and well-informed way. So, I want to thank both of you for doing what you're doing.
Thank you.
Thank you. We appreciate it. And we'll catch you next time.
Thank you.